Hello and welcome. I'm going to show how to design digital logic counters using different flip-flops. Example 1. Design the counter which has the following state graph using T flip-flops. First of all, we need to write the state table for the state graph. These three columns represent the present state, and these three columns with the plus sign represent the next state. And these three columns represent the T flip-flops. The numbers here, like any truth table, are binary numbers ordered from 0 to 7. Now let's write the next state. We obtain the next state from the state graph. So let's start with the state 0, 0, 0. 0, 0, 0. The next state is 1, 0, 0. So we write 1, 0, 0 in front of 0, 0, 0. So this is the present and this is the next state. Now let's go to 1, 0, 0. The next is 1, 1, 1. So this is 1, 0, 0 and the next is 1, 1, 1. Now for 1, 1, 1, the next is 0, 1, 0. So 1, 1, 1, the next is 0, 1, 0. And we continue like this until we fill all the table. We can see that the state 0, 0, 1 is not present in the state graph, so we just put dash, dash, dash. Now, to write the values for the T flip-flops, we need to follow this table. This Q represents the present state, and this Q plus represents the next state, and this T represents the value that we have to write in the T columns. Let's start with the TC. So let's look at the first number. We obtain this from the C here is 0 and the C plus is 1. So let's look at the table. 0 and the plus is 1. So we write 1 in the T column. Here we just have dashes, so we write X. We obtain the 0 from, let's look at the C here, 0, and the C plus is 0. So let's go to the table and see 0 and 0. We need to write 0 in T, and that's why we see 0 here. And we continue like this until we fill the column. So TC deals only with C and C plus. Similarly, TB deals with B and B plus. And TA deals with A and A plus. As we can see, this is the full table. Now we just need to put those values in a K-map or Carnot map in order to find the equations. In order to fill the K-map, we just need the values of the present states and the values in this column. Let's start with the first state, 0, 0, 0. We have 1. So CBA 0, 0, 0, we have 1. So we write 1 here. 0, 0, 1, CBA 0, 0, 1, we have X. So 0, 0, 1, we have X. 0, 1, 0, we have 0. So 0, 1, 0, we have 0. And like this, we fill all the blocks in the K-map. And finally, we write the equation for TC. And in the same way, we fill the K-maps for TB and TA. So this is the K-map for TB, and this is the K-map for TA. And these are the resulting equations. These equations that we obtained represent the inputs of the T flip-flops. This circuit diagram is obtained from the equations that we derived from the previous steps. We can see that we have three T flip-flops, C, B, and A. This input represents the clock. We considered synchronous operation in our design. TA, TB, and TC are the inputs of the flip-flops. The equation for TA was C plus B. So the C and B are inputs to an OR gate to give the equation of TA, as we obtained from the previous steps. These variables here, A, C complement, B complement, C, B, and so on, are obtained from the outputs of the flip-flops. So this is A, this A is the same as this A. And this is A complement, this is B, which is the same as this B, and this is B complement, which is this one and this one, and so on. Now we finish the design of the counter using T flip-flops. Example 2. Design the counter which has the following state graph using SR flip-flops. We're going to follow the same steps that we used in the previous example. However, we're going to use this table. In the SR flip-flops, we have two inputs, SC, RC, SB, RB, and SA, RA. Now to fill these two columns, we need to look at C and C plus only. We have 0 and 1. Let's look at the table. When there is 0 and 1, we have 1, 0 in S and R. So we write 1, 0. In this state, we don't have any value, so we just fill with x's. Now in this state, we have 0 and the next is 0. So when there is 0 and 0, we fill S with 0 and R with x. So 0 and x. And we continue like this until we fill the two columns. And in the same way, we can write all the values here. These two columns are related to B and B plus, and these two columns are related to A and A plus. As we did in the previous example, we need to fill all the columns in K-maps. And since we have 6 columns, we need 6 K-maps. So this K-map is RC, which is this RC. And this K-map is SC, so this is SC. In the same way, to fill this K-map, for example, which is RC, we just need to look at the present states and the column RC. Empty blocks here represent zeros. And this is the logic circuit diagram that we obtained from our design. This is the clock. Again, we have 3 flip-flops. This flip-flop represents the C flip-flop, this is the B flip-flop, and this is the A flip-flop. and these inputs are obtained from the equations that we derived from the previous step. As we mentioned in the previous diagram, this A, for example, is the same as this A, so actually it should be connected like this. However, we prefer to keep it like this for simplicity. We can design the digital counters using the JK flip-flops by using the same steps. However, we just need to use this table in our design. And to design using D flip-flops, we may use this table. Thank you very much.